Let's take a bit of a deeper look at the fundamental theorem of calculus. First of all, f, our function, has to be well behaved, so it's continuous on a closed interval between a and b. Let's just get that accepted. And the second fundamental theorem of calculus, the textbooks swap these around. Some textbooks say this is the first, some say it's the second. I'm going to say it's the second. This gives us the definite integral between a lower bound of a and an upper bound of b, which are just constants. And f is a function of x, and it just gives us an answer. It gives us a number. We plug in the numbers between a and we do the antiderivatives. We plug in the values of a and b, and we simply get an answer. That's the role of the second law. First, the antiderivative big F, where there's a big F, that's going to be the antiderivative of our function little f. Here, the lower bound is going to be a constant again, a, but the upper bound is going to be x. We're doing f of t to avoid using lots of x's in different situations here, and it just is there to avoid confusion. The upper bound is going to be our x, and that big F of x, the antiderivative of x, is really a function of this upper bound. So it's the upper bound that's going to be our f. Now let's just look at f prime. The prime of the antiderivative is just going to be the derivative of f of t dt between a and x, as we're writing out here. And f of prime of x is just going to be f of x. But what about this a? Doesn't seem to appear anywhere. Where does it go? Do we need to think about it a bit more? Well, let's just give ourselves a bit more space, and I think we'll look at the proof of taking the derivative of our antiderivative, df of x, and let's do it in the formal way. The limit as h tends to 0, approaches 0, of f of x plus h minus f of x all over h. It's just basically rise over run, written in a calculus way. Let's substitute what f of x plus h is. Well, it's the integral between a and x plus h of f of t dt. Subtract the integral between a and x of f of t dt, all divided by h. Let's get that in. Now, just writing the first one out again. But notice now I've put in a plus sign rather than a subtraction sign, but I've swapped over the lower bound and the upper bound. So now we've got an integral going from x lower bound to a upper bound in that latter integral. So I've now got two integrals which I can bring together because one goes from x to a and the other goes from a to x plus h. So I can combine these into one integral, limit as h tends to 0, the integral that's going from a lower bound of x to an upper bound of x plus h, and that a is now disappeared, and this is of f of t dt, all divided by h. So the a has disappeared inside this proof. But let's look a little bit closer at this integral, and let's recall the mean value theorem for integrals. Let's draw in our axes, draw in a function, give it a lower bound of x and an upper bound of x plus h. So the difference between these two, the interval is the distance of h. And pick a point somewhere in the middle here, such that the area above that line is going to equal the area below the line, above the line there. So those two areas average out such that we get a point C with an output of f of c, and the c is somewhere between x and x plus h, such that f of c is the average height. So that rectangle below f of c is the same area as below that curve. So f of c is going to be the integral of f of t dt between x and x plus h divided by, is its average, divided by that distance h. So now we've got the limit as h approaches 0 of f of c. And remember, c is between x and x plus h. We can see it on our diagram. Now, if h starts to approach 0, all these lines start to move to the left. Sort of x plus h approaches x, but that c approaches x. And as h approaches 0, f of c, the limit of f of c as h approaches 0 actually is f of x. Well, going back up to the top there, df of x, the prime of the antiderivative of x, big F of x, is simply going to be f of x. So it is the upper bound that is important here. That x, that value of x is the important. A doesn't appear at all. And we'll do an example of this in a minute.